All right, what is this next section? It is 2-4, or looking at scatter plots, correlation, and regression. And we will look at this in a lot more detail at the end of the class as well. So what is a scatter plot? A scatter plot's comparing two variables. So you're going to have a variable going across the bottom. Look at my example down here in red. You're going to have this one as waist circumference and arm circumference. So each dot represents somebody who we measured their waist and their arm, and their dot is that one person. So we're comparing two things. We love these for comparing a lot of different things. It's the great graph. We'll use it in a lot of business world. We'll use it in a lot of different math classes. So correlation, right, is a relationship between two variables, two ideas. Relationship. So if they're both growing together, like this red one down here, it is going to be a positive, right? They're both growing in a positive direction, so the relationship is positive. We cannot say one causes the other. We cannot say a bigger waist causes a bigger arm. We can say there's a relationship between if you have a bigger waist, your arm is typically bigger. Okay. We all know some dudes that can lift and their waist is little and their arms are huge. So it isn't, you know, you're not saying one causes the other, that it always is there. It's just a relationship. Okay. So we use the word linear correlation if those dots form a line. There's lots of other correlations. We really do focus on a linear. Do they form a line? Yes or okay. So would you do maybe highlight the line part there, whatever you want to use. Right, and here's my example of my scatter plot. So this first one has a positive relationship. As the waist gets bigger, so does the arm, right? Each dot, oops, I was thinking I was on the pointer, but each dot here is getting, as this one gets bigger, it goes up higher. Okay, then the dots could be crazy all over, and we could say no relationship, no correlation, no relationship, right? No correlation between those. Or we could have a negative, and this one forms a really good line. So this is a really good linear correlation in the negative. As you get bigger here, you're going down here. So you can make scatter plots in StatCrunch in that graph section, and we'll have a couple examples of that, but or you can draw them yourself, right? Over, up, whatever dot for each value. And these are all in the positive section of a graph. Okay, so we could also have nonlinear. So we talk so much in math about a linear relationship, but sometimes they don't have a linear. Maybe it is something for like if I think about the demand of an item, right? The demand is typically going to be a quadratic. It is going to be a shape of a parabola. So it's like, your demand is the price. Well, the demand of an item is always going to go up and then cave at some point. Okay. I don't know if that's the best example, but you kind of get my idea there. So how do I know if this linear relationship here is better than this one here? One's positive, one's negative, but how do I know which one's a stronger linear relationship? Well, I know that by the correlation coefficient, okay? And we label that with a little r. So the correlation coefficient is just a number, and the closer that number is to 1 or -1, the better the relationship is. Okay, and that's what it's saying here. Okay, right? It's between 1 and -1. So a negative relationship, ooh, sun in my eyes. Negative relationship is going to be going to -1, and a positive relationship will be going to the number 1. So if I have a negative 0.9, I have an amazing negative correlation. So we'll see that in some examples as well. We could also look at the regression line. So that is the equation of the line. Notice Instead of y equals mx plus b, we use these other weird symbols. This is the same as b, and this is the same as the slope, and they switch them around a little bit. But we're still asking that same thing. What is the regression equation that goes with that regression line? So if I'm looking at this, I want to form an equation so I can put in a value and predict based off that data. So we're going to compare two things. We're going to see what kind of relationship they have. I'm going to use the R to see the strength of that relationship, and I can use the equation to predict if they have a relationship. I don't care about the equation of the line if my data looks like that purple stuff right there, right? If it's not forming a line, I'm not using the equation of the line for a prediction. Okay, so a couple big reminders here. No linear correlation doesn't mean there isn't a relationship. It just means there's not a linear one. Okay. Also, I already said this, a correlation doesn't imply that one causes the other. So if I'm looking at the hours you study versus your grade, you cannot say one causes the other. You can say there's a relationship. The more you study, the better your grade is. Okay. This little symbol here, you're getting kind of used to that, but this little hat, it means sample. So when I say Y hat, it's of the sample. Well, we already know we mostly use samples in statistics. We don't do the whole population. So super common. So here's our first little set of data. Use the following data to create a scatter plot, find the R and the equation. So we need to do this in StatCrunch. Okay. So I'm in StatCrunch, but this one already has data in it. So maybe I'll just go to StatCrunch. Crunch.com. So you can always just go to StatCrunch and log in with your Pearson login anytime you want to use it. I don't want this data. Was it going to let me go? Where can I just do a new one? Hold on, let me pause my video and get this to clear. Okay, so I teach from my iPad, so it's a little bit different. So I'm like, I can't get it to be normal. So you might see this where you open StatCrunch like this, and you'll see data values and stuff when you click from Pearson, and then it should open blank like this one, untitled, unless you're opening a data set from your homework or from me, should open like this. But let's look at this data. We had shoe print. So I'm going to click in, and this first one was 29.7. And this is our shoe print. And what we're comparing on this one is your height versus your shoe print. So you would think as your shoe gets bigger, what do you think your height would do? It would be bigger. Okay, so next data value was 29.7. So we had 229.31.4. Oops. 4. And I'm just going to go down and then I'll go down. There's only a couple data values, 27.6. And then over here, it was 177. You're welcome to put this in as well as I do it so that you can learn how to do it yourself. But 185.4. And the last one, oops, did I miss one data value? 31.4 is 185.427. It's 172. I missed one. I'll just add it at the end. 172. The sun's in my eyes. I need to move my blind over here. I missed I don't need an emoji. 31.8. All right. So once I have the data in, where do you think I'll go to make a graph, which is called a scatter plot, right? So anytime, oops. Nope, it won't go back. That's the right one. You probably already fast forwarded me unless I messed this up. 175.3. All right. So Where do you think you should go? I'm going to go to graph, right? Because that's where all my graphs are. And I want to scatter plot. Lots of stuff in here. So our X value was our shoe print. Our Y value is our height. And pretty much everything else, we don't really need any of the grouping or anything like that. So here's our scatter plot like this. So that's how I can get to the scatter plot. Now, what if I want that correlation coefficient that tells me how good of a correlation this is? This is very little data values, but we can go to stat and it's a regression. So see the regression? This is what we're looking at as a regression, right? So simple linear because we're looking at linear, and we can do our shoe and our Y values is our height, and then kind of leave everything else the same, and I'll hit compute. So when I look at this, oops. Okay, so when I'm looking at this data here, I'm going to put it in a picture just so I can like kind of look at or show you what you see. Because I don't think I put it in here, did I? No. So I am going to think I can tell it to add a picture, maybe at the bottom. So I'll just go here. It's fine. So when I look at this, it won't let me right there either. Oh, forget it. It's not a big deal. So when I look at this, look at the top. Sorry. You see height equals 154. That's the equation of the line. It uses the words from your X and Y's. Instead of just Y equals MX plus B, it is giving you the words. The shoe or the height is equal to 154 plus 0.74 times the shoe print. So I took their shoe print size, I can times and add, and I can estimate somebody's height based off this data. So that is your regression equation, right? And this is all in that regression area. I cannot point to it, but you go down, you see sample size of 5, correlation coefficient is 0.25. Terrible. It's not close to 1 at all. Think of it like 25%. Not a very good relationship. So like we shouldn't even use that equation because this is not a good correlation between the two. Not a good relationship. But it is a positive relationship. The rest of this we'll look at later in the semester. But then you could see that fitted line to your data. Okay. So in order to get the equation or the scatter plot, right? We're going to go to stat, then we're going to go to regression. And that's going to go to simple, linear, and that's how you can get the correlation coefficient in StatCrunch. All right. Do freshmen in college really gain the 15 pounds? Here's some data sets of weights in September and again in April for freshman college students. What's the R value? What does this tell you about your data? And what's the linear regression? So it's all the same thing, but we get to, thank goodness, open this data. I don't have to type it in. And this is going to be our weights from September to April. Where do I go to get the whole everything, the scatter plot, the regression equation, and the correlation coefficient? I'm going to go to stat, regression, simple linear. Then I'm going to say my X values in my Y values and just push compute for now. And here we are again with this. I think I can do it this way. And then I think it'll let me write. Yeah, this is what I meant to do last time. Then I closed the whole thing. Like a silly goose. Okay, here's the equation of the line. Okay, and here is that correlation coefficient. So that correlation coefficient's huge. It's 0.94. That's super close to 1. It's positive. So this is a really good relationship. Okay, so you're positively gaining weight, and you could put your weight right here in September and see what's gonna be my weight in April. And it's a pretty good representation of that. So if I go back here, I can see my data on that um, scatter plot with the line of best fit on it as well. Okay, so I can go back, I can get the equation, I can get the correlation, I can see it's positive, close to 1. All of this p-value, these perimeter estimations, those we'll use later. And then this is the other part that you might want to use. So you'll probably in your homework have to pick which scatter plot and what is the R and what is the equation, the line of best fit. So I'm not going to fill this. Well, I guess I could fill it if I have it over here. So the R on this, just to fill out your little chart here, your R was like 0.94, which is good linear relationship. And it also is positive. And we know that because 0.94 is positive. If it was negative 0.94, they would have a strong negative correlation. Okay, and then the equation that we found was April is equal to, it was like 5.05 plus 0.94 times September. Okay, maybe I'll write in the actual September just because an S looks like a 5. That was our equation. And then review the R in this. Do you think the freshman 15, based off of this, there's definitely a relationship between gaining the weight. We don't really know if it's 15 pounds, to be honest, because we haven't figured out how to do the mean median mode yet and those kind of other information. So for now, I would definitely say you are gaining weight. There's a relationship between those. Another thing I wanted to say in this notes is you see that little, I circled it in red, you see this little box? That's how you can move your data to StatCrunch. Okay, you click that and you can move your data over. And then this is just one more example of finding that data, but I just wanted to show you, you have to click that there in StatCrunch or in your homework, quizzes, test, anything, and that will open the data for you. But I don't think we need another example. But there you go. That's how you can find that R and decide what kind of relationship something has and how to move your data over from StatCrunch.